Hi everyone, I want to take you through a quick journey of data security and encryption in the Blues ecosystem. And while security of our data used to be a bit of an afterthought, today it's a big deal to say the least. And we at Blues often shout from the rooftops about how secure your data is with Notecard and Notehub. So let's provide some more concrete facts to support those statements. Starting with the fact that no Notecard devices have publicly accessible IP addresses, making them virtually invisible to the public internet. Notecard also offers transport-level encryption, which is implemented differently on different types of Notecards. Lastly, you can optionally encrypt the data you send with Notecard. So let's start with transport-level encryption. This refers to your data being secured while in transit. And start with the Notecard Wi-Fi. This is an easy one, as TLS encryption is standard and always enforced when using Wi-Fi, even when using Wi-Fi on the Notecard Cell plus Wi-Fi device. Now next is Notecard LoRa. It's another easy one, as the transport is always encrypted again using standard LoRaWAN transport encryption. Now what about satellite data with StarNote? Well, for downlink data, it's always encrypted using my favorite algorithm name, ChaCha20 Poly 1305. As an extremely bandwidth constrained protocol though, uplink data is not encrypted by default, but to enable transport encryption on uplinks, you simply name your note file with the QoS, QIS, or DBS extension, depending on your need. Now last is Notecard Cellular, and this is where it gets slightly more complicated. If your hub.set mode is set to continuous, TLS encryption is enforced, end of story. If, however, it is in periodic or minimum mode maybe, the first sync after boot uses TLS encryption to exchange keys, but subsequent syncs do not to save bandwidth. However, you can always force TLS encryption no matter what, again by using the appropriate file extension for your note files. So in summary, with Wi-Fi and LoRa, transport level encryption is always taken care of for you. On StarNote, if you want uplink data transport encrypted, be sure to use a secure note file naming convention. Likewise, on cellular, continuous connections use TLS, but otherwise you can enforce TLS again using a secure note file naming convention. The only real downside of using those QoS, QIS, or DBS file extensions is slightly higher data usage due to the additional overhead required. So that's transport level encryption, which I would argue is probably adequate for 99% of your use cases. However, if you also want to encrypt the data payload itself, for instance, if you are syncing any secrets or other data that needs an additional level of security, we have a solution for you, and that is encrypting that data payload. So in a nutshell, using an AES-256 symmetric algorithm based on a public key you specify, the Notecard can encrypt outbound notes added by your host, pass that encrypted data securely to Notehub, and Notehub will pass that encrypted data securely to your cloud. Your cloud can then decrypt the data with your key pair. And of course, this works both ways as well. So you can encrypt data in your cloud, send a secure inbound note to Notehub, and pull that data into the Notecard for decryption on the device. So let's quickly walk through the Notecard to your cloud path. You'll start by generating an ECC key pair using the SEC P384R1 curve with OpenSSL. Now, if you're already like, whoa, slow down, rest assured we have this entire process documented on the Blues developer site at this URL. Now, once you have that key pair, you're going to need to add the public key as an environment variable in your Notehub project, making sure to prepend it with the curve and algorithm as displayed here. Now, you'll then use the arbitrary name of the environment variable to tell the Notecard which key to use to encrypt your data. So you'll copy the complete contents of your public key file into the value field for this environment variable. Now next, you're going to use the note.add API to add a new note that you want to encrypt. The only thing that's different here than the regular method of adding a note is adding the key argument with each request and providing the name of the environment variable you just added to Notehub. This will store the encrypted data in Flash on the Notecard. And then you'll sync Notecard with Notehub and you'll see the encrypted data appear. Finally, you'll route your data out to your cloud application, again, just like you would do with any other note. And that note will look something like this, right? Not so human readable. But how do we decrypt that data on our own cloud? Well, you're going to go through decoding that base64 encrypted AES key and decrypt it using your private key. You'll then decode the base64 encrypted data and decrypt it with the decrypted AES key from the previous step. Is that too much to remember? Certainly is for me, which is why we offer pre-built sample code for Bash, Node, C#, and Python implementations. And of course, bookmark this link for access to the complete guide with code. Now lastly, I want to touch briefly on data security on Notehub itself. And there are three things I want you to know today The first is that all of your data is isolated and stored in separate database instances in Notehub. We also take hourly, weekly, and monthly data snapshots to ensure data integrity. And any remotely private customer data, otherwise known as PII, that's always encrypted on our servers. Now that's it. I hope you're inspired to learn a little bit more about data encryption with the Notecard and Notehub. And of course, the best place to start is our encryption guide right here. Thanks for watching.